So we're beginning Unit 10, and I'm sorry that my face is so big in this video, but I really want for this lesson for you to be able to see my periodic table, so I have to kind of do a close-up here. But in this unit we're going to be looking at the periodic table and how different trends happen on the table. We're going to be pulling together lots of things that you have learned about earlier this year and putting them all together, and hopefully you'll be able to make some connections between different units that we've studied and be able to see why things work the way they do. The periodic table is an amazing thing. But to start with our first lesson, I just want to get some of the organization out of the way, some of the vocabulary, so that you can see the different areas of the table and how we name them. So let's start with the simplest thing, which is just to look at where are the metals and the non-metals located. So I'm going to be out of this video for a lot of the time so that you can just see the periodic table. So over here, all of this area right here, up through here, and all of this are the metals. So if you have the handout that I gave in class, or if you were able to get the handout, you can be filling that in as we go along. If you don't have the handout, you actually might want to wait until you get it before you do this exercise. The non-metals are up here, plus hydrogen, because hydrogen obviously is not a metal. So we've got all the non-metals here, plus hydrogen, all the metals over here. This area in here are called semi-metals, or metalloids. Semi-metals or metalloids. And those have some metallic character, but they're not really metals. They don't have all the metallic character that the rest of the metals have. So let's talk for a minute about what we mean about metallic character. We already learned about metallic bonding. So we learned that the metals have those valence electrons in the outside that easily move around. They don't stick with their atom, they're all over the place, they're shared by all the atoms in the whole chunk of metal, and that means that they freely conduct electricity. They can conduct a current if we have these electrons and just moving all over the place. They can also conduct heat really well, so those are two characteristics of metals. And you probably noticed all of this and all of this. Most of the elements that we know about are metals. Most of them are solids, with the exception of one. Only mercury is a liquid. So we have solids. We can't really make any statements about how hard they are. The metals that we're familiar with, of course, are quite hard because we use them for things. And the softer metals aren't very useful. If you could take a butter knife and cut through it, it wouldn't be very useful for building a skyscraper out of, or even a piece of silverware, especially if it was put into water and burst into flame. That would be bad, and some of the metals do that. So we have to use some metals for structural things, and other metals we use more for chemical reactions. But anyway, so softness and hardness, there's a lot of variety among the metals, but they do all conduct electricity. They're all nice and shiny. They're all malleable, and that means that if you hammer them, they will not break apart. They're not brittle, but if you hammer them, you'll make a dent in it. And if you hammer it a lot, you can hammer it out into a sheet. Now they knew that even back in Bible times, because if you remember the story of building the temple, they took gold and hammered it out into thin sheets and used it to decorate the inside of the temple. I mean, the altar, right, was covered with gold, and some of the door frames and things like that. And then some king came along later and stripped it off. But anyway, metal can be hammered into thin sheets, and that's called being malleable. And it can also be pulled out into wires, and that's called being ductile. They tend to have luster, they're shiny. Most of them are silvery, not all of them. For example, copper is not silvery, but most of them are silvery. So they have a lot of things in common. Now, we can't say too much about the properties of nonmetals because they're all over the map. We've got gases over there. Gases, gases, gas, gas. We've got even one liquid. Bromine is a liquid. And we've got a few solids like carbon and sulfur and phosphorus. Those are all solids. So there's just properties all over the place. Some of them are very reactive, some of them are not reactive at all, and we can't really make any statements about them. So semi-metals, though, have some properties like metals and some properties not like metals, and so they can be made into semiconductors. For example, silicon and germanium are used in the semiconductor industry a lot. All right, so let's move on to other things. Some of these families have names. Now, a family is a vertical column. So we have lots of vertical columns here, and those are families or groups going across like this. Those are called periods. Now, some of the families have special names and some of them don't. Some of them, for example, might just be called the carbon family if carbon's at the top of the row, or the oxygen family. But others have special names like the noble gases. You are familiar with those because we've talked about those before this year. So group 8A are noble gases. Group 7A are halogens. I don't think I've used that word much this year at all, but that's just the family name given to that group. Back over on the other side of the table, group 1A are called alkali metals. Alkali metals. And group 2A are called alkaline earth metals. Go back up here and so that's group 2A. So we have names for 1A, alkali metals, group 2A, alkaline earth metals, group 7A, which is called halogens, and group 8A, which are the noble gases. Now, in the center of the table, we have this great big chunk. Those are called transition metals. Transition metals. This great big chunk here is called inner transition metals. So transition metals and inner transition metals. Now, the last way that the table is divided is not going to make a whole lot of sense to you right now because we're going to cover this in a later lesson, but I want you to just see it now so that we can kind of chunk up the table and we can refer back to it later. So don't worry if you don't understand what's going on here. But we're just using letters. And the four letters are S, P, D, and F. And the S block is over here. It's these two columns right here. That's called the S block. The P block is right here. It's these 6 columns over here. The D block is over here, and this is 10 columns right here in this chunk. It's actually the D block and the transition metals are the exact same thing. And the F block are the same as the inner transition metals. So that's how we chunk up the periodic table, and that kind of gives you the overall organization of it, and then we'll be looking at this in a lot more detail in the next lesson.